Today we will learn about sector area of a circle. So a sector area of a circle, another way to think about this, is a slice of a circle. So here's my full circle. We'll do a slice of it and find this area. So let's start with the full circle. Area for a full circle is over here, which is something you should have learned in middle school. Area of a full circle equals pi r squared. Now to find area for a sector, it's a proportion. So we have this proportion. Where your sector area over your full area equals your angle measurement over your full angle. The way I describe this is part of the area over the whole area equals part of the angle over the whole angle. Part over whole equals part over whole. So let's take a look at that in this example. Over here, I want to find sector area. So to find sector area, first we need to find area. So area of a circle, pi r squared. I'm going to fill that in. 12 squared is 144. So area is 144 pi. Over here, let me make a note. This is what we call leave answers in terms of pi. What this means is this pi right here, we do not type in the calculator. This is what we call our exact answer. So over here, 144 pi. This is the same as 452.39. So over here in green, answers in pi. Over here in blue, this is what we call our decimal answer, or our rounded answer, approximate answer. So for the rest of this section, I'll be working with answers mostly in pi. Reason for that is when you go to an upper level course such as pre-calculus, they tend to stick their answers in pi. Because this is a more accurate answer, this is a rounded answer. So there's my area, 144 pi. Now we can set up our proportion. Proportion will be this part over here to my left. Proportion is, we don't know what sector area is, so I'll call that x. X over my full area of 144 pi equals my angle right here, 60, over my full circle, 360 degrees. Okay. So at this point, we cross multiply and solve. X times 360 to get me 360x equals, then we have 144 pi times 60. So on my calculator, notice I'm going to do 144 times 60. I am not typing pi in. So this is 8,640, and then I just write pi because there's still that pi over here, just moves over there. And last step, to get x by itself, we divide by 360. So again, when I type that in, I do 8,640 right here, divide by 360, don't type pi in. to get x equals 24 pi. So what this means is my full circle is 144 pi. This slice of that circle, this area of this part, is 24 pi. So that's sector area in a nutshell. Now let's take a look at the second example. Next, we will have what we call segment area. Alright. For segment area, you still need to find sector area. But segment is talking about this line segment right here. If I connect this end with that end, drawing a chord, what's the area of that green part? So, the green shaded area. Is my segment. So we do that by finding sector area, and we subtract minus the triangle. So that's the idea behind segment area. So we need to find two areas here, the sector and then the triangle. So let's start with sector area. For my sector area, let's go ahead and find my total area. Area equals pi r squared, which is pi 12 squared, which gets me to 144 pi. Is that full part. Now I set up my proportion to find my sector. X over 144 pi. Part of the circle over the whole circle equals part of the circle 60 over the whole circle 360. Cross multiplying and solving. X times 360 gets me 360x. That's this part. And then 60 times 144 gets me 8,640 pi. Last step, divide by 360. X equals 24 pi. Which, if you would notice, is the exact problem I have up here. Okay. So that's sector area. Now we need to find area of the triangle. Triangle area. So this one's tricky, and let me show you how to do this. Area of a triangle is 1/2 times base times height. But we need to identify what's my base, what's my height. So the hint here would be that 60 degrees. Remember, in our previous units, height of a triangle is the altitude, which goes from vertex to right angle. So I will draw a right angle over here. 90 degrees, which then makes this part 30 degrees because I cut that 60 in half, and it makes this angle over here 60. So we have a 30, 60, 90 triangle. And in a 30, 60, 90 triangle, we have the hypotenuse we're trying to find, short leg. So from hypotenuse to short leg, remember our rule is divide by 2. So 12 divided by 2 gets me 6, which means this side over here is 6. And then my next rule, from short leg to long leg, multiply by square root 3. So 6 times square root 3 equals 6 square root 3, which is my leg over here, 6 square root 3. This part is 6, which means my entire base is 12. From here to there is 12. This segment is 12, 6 plus 6. So now we can find area of that triangle. Area of that triangle is 1/2 times base, 12 times height, 6 square root 3. And let me go to my calculator for this. One half times 12 times 6 square root 3. 62.35 is the area of my triangle. So finally, to find my final area, over here I wrote sector area minus your triangle area. So we have 24 pi minus 62.35. This time I do want to type pi in the calculator because I am looking for decimal answers. Because we are subtracting something with pi and something without pi. So I need to have that decimal answer. Right. So this tells you that the area of this green shaded part is 13.05. To give you a perspective, 24 pi, which was the area of this whole thing right here, this sector, that slice. The area of the slice is 75.4. The area of just the green part is 13.05, just to put some perspective into it. Alright, so there you have sector area of a circle. What I'm going to do next is I will work on some further examples before I wrap this video up. Alright, so these are questions from one of our worksheets. Alright, so one of these, number 3, gives me a picture like this. I have a radius of 50 and it's asking me to find one sector. Okay. So first is, what is the angle? We need to find that angle. We know that this is a picture of a semicircle. And that a semicircle is 180 degrees. And you can see that these three angles are congruent. So you have 180 degrees divided by the three congruent angles to get 60. And that's how you find that this angle is 60 degrees. So now we can work with our areas. Area equals pi r squared. So my area is pi times 50 squared, which is 2,500 pi. So now we can plug this in our proportion. We don't know what our sector is over, but we do know the full circle is 2,500 pi. That equals 60 over 360. Cross multiply. 360x equals, use my calculator for this big number right here, 60 times 2,500 is 150,000. 150,000 pi. Then you divide that by 360. And we have x equals 416.67 pi. Alright. Next problem. Over here, this example is just straight up sector area. Area equals pi r squared, which means pi 80 squared. 80 squared is 6400, so we have 6400 pi for my total area. Then we throw this in the proportion. We don't know what the sector is, so we call that x. X over 6400 pi equals my angle right here, 160, over your full circle, 360. Cross multiplying, we get 360x equals, let's go do 160 times that 6400 to get 1024000. And last step, we divide by 360. We get x equals 2844.44 pi. And my very last example. Alright, bear with me here. Once again, we have that segment area. So first, I need to find the sector area of this entire slice. Area of my slice. Again, we need area, pi r squared, which makes it pi times 70 squared. 70 squared is 4,900. And then we set up our proportion. X over 4,900 pi equals 105 over 360. Cross multiply, we get 360. X equals 105 times 4,900 to get that number over here. 514,500. And last step, we divide by 360. To get x equals 1429.17 pi. And I will go ahead and type this in as a decimal. 1429.17 pi. Which as a decimal is 4489.87. Again, reason I want this as a decimal is because I'm eventually going to subtract this triangle. So let's go ahead and find that triangle. To find that triangle, what we need to do is to cut that in half, draw an altitude. So 105 cut in half gets me 52.5, which means this angle right here is 52.5 degrees. This hypotenuse is still 70. This time we are using SOHCAHTOA to find your opposite and your adjacent. I'll start with opposite. Opposite to this angle, if opposite and hypotenuse, that's cosine. So cosine of 52.5 equals opposite over hypotenuse. Because x, in this case O, x is on top, we multiply. What we mean by multiply is, well, first in my degree mode, let's go ahead and move to degree mode. Multiply 70 times cosine 52.5. So opposite equals 42.61. Now let's find our adjacent. Adjacent, We have adjacent and hypotenuse. I apologize, adjacent was cosine. What we're missing is opposite, which goes with sine. So sine 52.5 equals opposite over 70. So over here, 70 sine, 70 sine 52.5, 55.53. This side is 55.53, which means I need to double that to get my entire base, 27.77. Oops, that's not right. Press the wrong button. 111.07. This part is 55 right here, so I double it to get from here to here is 111.07. So now area of a triangle equals 1/2 times base 111.07 times height, which is, where am I, 32.61. One half times, here's my base, times, here's my height. Just grab using the calculator to grab those numbers. So area of that triangle equals 2,366.52. And you may have rounding errors here depending on how early you rounded. Finally, we can find the green shaded area. We do that by taking the black area, this part, minus the blue area, that triangle. So we have 4,489.87 minus 2,366.52. To get 2,123.35. This is my area for just that green portion right here. Alright. So, recap. Sector area deals with proportions. It's part of the sector over the whole circle equals part of your angle over 360 full circle. So here's that in action. Example of a sector area. We want our answers in terms of pi. That means do not type pi in the calculator. I want this answer, not this. So there's my answer in pi. And we can also cover segment area, which is a bit more involved because segment area requires us solving for triangles. And when we're solving for triangles, we can either use special triangles, 30, 60, 90, to find those parts, or what always works, SOHCAHTOA, to find those parts.